Modelling with quadratics. A mathematical model is a mathematical description of a real-life situation. Often there is a certain amount of simplification, which means the model is easy to work with, but we can get reasonable results. So there's a little bit of give and take with this. You want a model that you can work with, but also provides you good results about a real situation. This may be an iterative process, one in which our model is refined so that it better reflects real results. A good model should be able to predict the outcome of a similar problem. An example would be a hanging cable or chain, which actually hangs in a shape called a catenary. And that would look something like this. The actual graph shown here is y equals cosh x, or e to the x plus e to the negative x divided by 2. So that's a function that you won't have met yet in your mathematics. This function is more difficult to work with, at least at this stage for you, than a quadratic. So can we get a quadratic close to this curve? Well, here's an attempt. And that one is y equals 0.75 x squared plus 1. And we can see it's close in places, but not in other places, and slightly different at the end points. So can I do better than that? Well, yeah, I've got this green quadratic here, which fits fairly well. And that one was y equals 0.6905 x squared plus 1. And this is part of that iterative process. I tried this, and then I adjusted it a bit until I got this one. It might be possible to make some further refinements to this so that it fits a bit better just here. You can see there is a gap between them there. But this does fit exactly at the two endpoints and at the y-axis intercept.